Welcome back. In this video, we consider yet another example for Green's theorem. This time around, we are to evaluate the integral around a triangle as well as around a circle. If you have not yet followed us, make sure to like, share, and subscribe, and turn on your notifications so you do not miss any of our videos. Now, let's begin. The very first thing we want to do is have a clarity as regards to how this movement is done. Now, it doesn't have to be an exact representation. It's just good if you have clarity as regards to how this transversal is done. Now, I'm going to make a rough sketch for the triangle case, and then you can also make a rough sketch based off the circle case before we do so in that part of the question. So this doesn't always have to be drawn to scale. It's just to give you a mental perspective as regards to what exactly is going on within your shape. So we have, of course, we can say this is 1, 2, and this is 3. So this is 3, 0 here. This is 0, 0, and then this can be 3, 2. So where you have 1 and you can have 2. So basically, we're saying counterclockwise. So we're going here, here, and then back here. Right. So a full motion is completed. Right. So we are completing the full motion here. Of course, this is for the triangle, and we have written out the vertices. Now let's start. If we label this, we can have this as A, we can have this as B, and we can have this as C. Then for the triangle ABC, we see that we can move along the paths of AB, and then we can move BC and then CA. That's what it means to go counterclockwise. Clockwise would have been AC, CB to BA, but we usually go counterclockwise. Now, along AB, let's evaluate what happens along AB. We notice that this is just the real line, the real axis line, which is basically an horizontal line, which means in that case, there is no vertical movement, right? You go in from 0, 0, cross to 3, 0. So y, the y value is fixed, which means in that case, the equation of this line here is simply y equals 0, and then the differential of y is also 0, right? So you differentiate a constant. Now, if this is the case, then we can say that the integral along AB, right, where I is this integral here, so you can basically make a simple substitution and say let I be equal to integral here there we go. Now we can simply make the integral define the integral along AB. This time around, since we're moving from 0 to 3, we've seen that y equals 0 is the equation, dy is equal to 0, and then we would only have the x and the x variable remain. Y will be 0, dy will also be 0. So this will simply be the integral from 0 to 3, and then you would have 2x plus 4 dx. The entirety of this bracket will vanish because you're multiplying by dy, so obviously it will vanish. So here, what are you going to have? This would simply be x squared plus 4x, evaluating the bounds from 0 to 3. Now, the lower bound will completely be 0 because it vanishes. So you're going to have this to be 3 squared, which is 9, plus 4 times 3, which is 12. So here, what we are going to have is 21 on the first part of the motion, right? So the integral along AB would simply be 21. Now, along BC, what would happen is this time around for BC, we are going to go from 30 to 32, right? From 30 to 32, of course, if you evaluate, this would mean that our x value is the one fixed here. So x equal to 3 is the equation. and then dx will be equal to 0. So if we evaluate that into the integral over bc would this time around simply be the integral. Now remember, we're going counterclockwise, so this is the start point and this is the end point for that line. So you have integral from 0 to 2, right? So x turns to 3 and then dx goes to 0 and every other thing remains. So dx goes to 0 reduces this first bracket and then you have the second bracket left. So you have 5y, right, plus 3 times 3 is 9 minus 6 multiplied by dy. So this, of course, means that you have the same thing as the integral from 0 to 2 of 5y plus 3 to y. So if we evaluate this, this is simply going to be 5y squared over 2 plus 3y from 0 to 2. So this is going to be 2 squared, which is 4, that's 2, that will be 10 plus 6. So we have that the integral along BC would be 16. So now we have evaluated the integral along two paths. And then the last path would simply be CA, C to A. Right, so this will be our start point and this will be our end point in this case. Remember, we're going counterclockwise. So along CA, so that would simply be 3, 2, 2, 0, 0. We notice that in this case, none of them is fixed, right? So we would have ourselves the equation of a line. So of course, if we use the 2-point strategy, we would have in this case that y minus 0 divided by x minus 0 would simply be 2 minus 0 divided by 3 minus 0, right? So we're using these two lines or these 2 points. So in this case, we're going to have that y over x equals 2 over 3, which would mean immediately that 3y equals 2x, right? So 3y is equal to 2x. So in this case, regardless of which of the variables you use, you are going to have yourself a fraction, right? So you can now decide, do you want to make your substitution in terms of y, or do you want to make your substitution in terms of x? Now, let us make our substitution in terms of x, thereby eliminating y. In this case, you would have that y would now simply be equal to 2 over 3x, which would mean that the y would now be equal to 2 over 3 dx. So all we would have left would be x in this case. Now, because we are making our substitution in terms of x, that would mean that we would only be using the bound values for x, right? We would only be using the bound values for x in this case. Now, what exactly would that mean? That would mean, without a doubt, that when we evaluate based off this, the integral along CA would now be the integral values along x, which is the integral. Don't make a mistake, we are starting from C and we are ending up at A, right? So the lower bound will be 3, the upper bound will be 0. These are the values of 3 to 0. So very, very important. And then wherever we see y, we substitute by 2 over 3x, and wherever we see dy, we substitute by 2 over 3 dx. So here we are going to have 2x minus 2 over 3x plus 4 dx plus 5 multiplied by 2 over 3x plus 3x minus 6 2 over 3 dx. This is what we're going to have, which is quite extensive. So we can decide to multiply this out. We can decide to take LCM. This will simply be integral from 3 to 0 of, this is going to be 6x minus 2x, right? So 6x minus 2x plus 12 all divided by 3 dx, right? And then on this other side, LCM is 3 still. We're going to have 10x right, plus 9x minus 18 all divided by 3, and of course multiplying 2 over 3 dx outside. So this gives us a good start point that we can go into. Now continuing on this, we would have that the integral along CA would be the integral 3 to 0. So for the first bracket, we would have reduced to 4x plus 12 over 3. Of course, this is the x. And then on the other hand, we're going to have, do not forget that on the other hand, we have a 2 over 3 outside, which we would still have to expand. So this is 19x times 2, and then this is 18 times 2. So we are going to make those instances as well. So 19 times 2, that gives us 38x minus 36 divided by 9 dx, right? So this is what we have. Now, of course, from here, we could decide to collect like terms, or we could decide to factorize out 1 over 9. So factorizing 1 over 9 would mean that every single thing left in the integral would be in whole number form. Now, in this case, on this part, what would we have? We would have to multiply this by 3. So we'd have 12x plus 36, right? And then on this side will remain plus 38x minus 36 dx. So what amazing thing happens? We see that the constant cancels out. So 36 minus 36 is 0. So we'll be left with 50. So you have 1 over 9 integral from 3 to 0 of 50x dx. So all is well that ends well. So from here, if we evaluate this, we would have this to give us 1 over 9 50 x squared over 2 evaluated from 3 to 0. Now the upper bound in this case is what vanishes out as 0, and then the lower bound exists, so we're going to have minus 50 multiplied by 3 squared divided, of course, by 9 times 2. So 3 squared, of course, gives us 9. 9 divided by 9 cancels. 2 cancels. In 50, you have minus 25 left. So the integral over CA gives you minus 25. So we now have the 3 parts done. So we have that the value of I, which is going to be the sum of the integral along AB plus the integral along BC plus the integral along CA, this would now give us the addition of their values, which from our previous solutions, we've seen this to be 21 plus 16 minus 25, right? So in final result, this I would simply be 12 as our final answer. So that would tell us that the evaluation of the integral along the triangle of vertices 0, 0, 3, 0, and 3, 2 transversed in the counterclockwise direction will indeed give us 12 as a result. Now, at this point, you can take a pause to consider what happens when you transverse the triangle in a clockwise direction. So when you transverse the angle in a clockwise direction, what happens to your result? What happens to your value? You'd find out that this would actually give you something very, very, very interesting for you to consider. So look at what happens when you transverse in the clockwise direction. Compare the result of the integral you have to this value, and let us know, or let me know your conclusions in the comments.